Hey guys, today I'm going to teach you this amazing thing about the use of fx9750 to draw bending moment diagram and shear force diagram. If you are an engineering student, you'll surely know its importance. So, I'm going to teach you to draw the shear force diagram and bending moment diagram for the beam uniformly distributed, simply supported beam as shown in the figure. The shear force diagram and the bending moment diagram are like this. So we are going to draw these two figures from our calculator fx9750. So our calculator will help us to find this point at what is this distance at which this value is 0. For this case it is simply supported, so we can tell that the zero shear force is at a distance half of the length, and the maximum bending moment diagram also shows that its maximum value is at the half distance, right? But if the support conditions are altered, these values will fluctuate. So I can tell the maximum value uh, by just looking at this graph, what is the maximum value. So overall, what I'm going to teach you is that I will teach you to locate these main points and show you the nature of this graph. Okay, for this, what you should do is you have to calculate the reactions first. Okay, for example, in this beam, the beam is of length L and the uniformly distributed load is Q kilonewton per meter. Okay, and the reactions are Ra and Rb. So let's assume that Q is 10 kilonewton per meter and the length is 10 meter. Okay, then the reactions Ra and Rb are equal in this case. So it is QL divided by 2, and they are 50 kilonewton and 50 kilonewton. Okay, so if we have to draw the shear force diagram and bending moment diagram, we have to cut the section and look the internal force at any section. Okay, so at a distance x, I'm going to cut this beam to look its shear force and bending moments. Okay, so for shear force, if I cut at this section, the shear force will be Ra minus the force given by this loading, right? So the force given by the uniform load will be Q times the distance Qx minus Ra. Okay, and the moment value will be the moment given by Ra minus the moment given by the uniformly distributed load. The thing that matters is the direction of the reaction and the uniformly distributed load are different. So one is minus, the moment given by one is minus and the other is plus. Okay, similar is the case for shear force. Okay, so the thing we have to do manually is that we have to find this equation. For example, the shear force equation is 10x minus 50 and the moment equation is 50x minus 5x squared, and that is what I just told you, the way to find this equation. Okay, if you get this equation, then I can show you how to draw the bending moment diagrams and shear force diagram in our calculator and to locate these pinpoints, and these are the points of interest to us. Okay, so let's draw the shear force diagram first, and the equation is 10x minus 50. So the resulting value will be in y, right? So just go to the calculator and select this graph. Okay, and click on OK, and in here we already have a line, so I'm just going to delete it. Okay, so our equation is in the form of x, right? For certain value of x, I have to calculate the value of y. Okay, so if it was in the form of 10y minus 50, I have to change the format, and in here there is a type, right? Just click on F3 and it says what is the equation like. Is it like y is equals to something or x is equals to something? In our case it is like y is equal to something, right? So just click on F1. So it is like y is equals to 10x minus 50. So I'm just going to type here 10x minus 50. Okay, so click on exe, And when you go downward and click on exe, then I'm seeing a graph, but I cannot see it clearly because the scale is not that I wanted. So what I want is I'm just going to manage its scale. Okay, click on shift and view window F3. Okay, and it says that the value of x ranges from -6.3 to 6.3. Is it true? No, absolutely not, right? Because my value of x ranges from 0 to L, right? And L is 10. So I'm going to edit this value. My minimum value is 0 and click enter, and maximum value is 10, right? Okay, and scale 1, it's okay. I'm again going to execute it, and I can't see my graph. Okay, so again click on view window, and we have changed the value of x, but we haven't changed the value of y. Okay, so what could be the value of y? It is the shear force, so let's assume the maximum value is 100, and sorry, it is the minimum, so it is minus, and enter, and for plus value, maximum value, it is 100. Okay, and exe, and this is it. So just click on exit and execute. Yes, now let's compare to the value that we have in this graph. So yeah, it is similar to the shear force diagram in this Word file, right? In the calculator we get this graph, so we have to locate this point. At what point is this value shear force diagram 0, and at a distance x is equal to 2, what is the shear force value? So for that we have to click on shift trace. Okay, trace, and I'm just going to enter one number like 5. Then it takes value of that value 5 is x and calculates the value of y. Okay, so just click on execute, and it says that at x is equals to 5 the value of y equals to 0. So just click to enter, and it says that at x equal to 2 y is minus 30. Okay, so you can arrange the direction of shear force accordingly, right? If you want, if we want this side to be positive, so in here it should be 50 minus 10x, and we can get the shear force diagram positive. Okay, so for the bending moment diagram we'll do the similar thing, and exit this and just delete this one, and the equation is 50x minus 5x squared. So it is 50x x minus 5 squared. Okay, and click on enter. Yeah, we're seeing a graph, but it is not completely viewable. Okay, so we have to manage the windows. Click on shift plus view window, and the value of x minimum is okay, it is from 0 to 10, right? But the value of y, it is different. For bending moment diagram the value is bit larger than the shear force, so let's make it minus 300, and maximum is 300. Okay, enter and enter. Yeah, this is the diagram that we want. And now I'm going to give you, click on 5, but before that we have to click on shift trace and just click 5, Okay, click on shift and trace, and it says that at x is equals to 5, y is 125, right? And if I want at any point x is equals to 2 the value of y, then it just click on 2, it will be x, and it says that at x equal to 2 y is 80. It's pretty cool, right? So we don't have to work so hard if we have this calculator and if we have the knowledge to draw these diagrams. So hope you learned a lot from this, and thank you for watching.